So I'm going to be working through this quiz number 2. You're more than welcome to write things down as I go along. It's dealing with rational exponents and how to solve exponential equations using rational exponents. I'll be having some help here with one of my students, also known as C. Swizzle. Apparently, that's what he's called. Yeah. Anyways, so we're going to go ahead and start right here and put 625 over 256 raised to the power 5x minus 4, and that's all equal to a 1, and we got to solve for x. Now, if you know anything about exponents, you know you have to have the same base. So watch this. Watch me make the same base. I'm going to take that 1 away. I'm going to erase it. I'm going to put 625 to the power of 256. I'm going to raise that sucker to the power of 0, because any number other than 0 raised to the power of 0 is 1. And if you don't believe me, all right, I'll prove it. I'll prove it to you. Okay, if I can find there's my calculator. All right, prove it. Here we go. Calculator loading up. All right, loading. Clear that out. All right. So let's say you had $1 million in the bank, but you raise that to the power of 0. It's 1. Ooh, what if you owed somebody $1 million? Okay, I want comma. Okay, good. Well, you know what? If you want to change that to a 1, just raise that sucker to the power of 0, and voila, it's a 1. So any number raised to the power of 0 is 1. Now, once you have the same base, see how these are the same base? Right, same base. Now, what can I set equal to each other? I can set this equal to this. So all I got to do is set 5x minus 4 equals 0. Add 4 to both sides. We get 5x equals 4. Divide both sides by 5. And what's my answer? 4 over 5. And C. Swizzle agrees. It's 4 over 5. Totally. He says totally 4 over 5. All right. Boom. Nailed it. Okay, we've got to solve for x. So we're solving for x right now. All right. Now, if you look at this carefully, you'll realize that these are not the same base. This is not the same base as this. All right. Now, this is where understanding your 4s or understanding your 2s is very important. So watch this. 4 cubed is 64. Okay. And 2 to the power of 6 is also 64. Well, 4 to the power of negative 3 is 1 over 64, and 2 to the power of negative 6 would also be 1 over 64. So I can actually use a 4 or a 2. Well, since a 16 can also be used, I can get 1 over 16 with using a 2 or a 4. Like 4 squared is 16. So 4 to the power of negative 2 would be 1 over 16. I could say also 2 to the power of 4 is 16, or 2 to the power of negative 4. So I could use a base 4 or a base 2. So what am I going to use? I'm going to use a base 4. I just think it's easier. So watch what I'm going to do. I'm going to change this guy to 4 to the power of negative 3. We have a negative 2x plus 6 equals 4 to the power negative 2 raised to the power of 8x minus 5. Now, students will often forget that when you have power to a power, you got to multiply everything. So I want you to put this in parentheses. That kind of reminds you need to multiply. So I'm going to distribute that negative 3 to both numbers and that negative 2 to both numbers. So we have 4 to the power of 6x minus 18 equals 4 to the power of negative 16x plus 10. Now, once you have the same base, what are you allowed to do? You're allowed to take this set of exponents and set it equal to that expression up there. So these expressions are now equal to each other. So now I can just simply write 6x minus 18 equals negative 16x plus 10. Okay? So I'm going to solve for x. Add 16x to this side, add 16x to this side. I get a total of 22 x's. Add 18, I get a total of 28. So what am I left with? 22x equals 28. Then I divide both sides by 22. All right. Now, I can simplify this because 2 goes into both, so I could reduce that to 14 over 11. But if you have access to a calculator, you could still do 28 divided by 22, and then hit the math button and press enter twice, and it still gives you that 14 over 11. That's my answer for x. Okay, so x is equal to 14 over 11. So I'm going to clear this out. 14 divided by 11. All right. So now I'm going to try to teach you guys how to evaluate this. Now you have a calculator, so this one's kind of a gimme. You can just type it in the calculator and you'll get the answer. But let's see if we can do it without a calculator, okay? All right, so what I'm going to do is I'm going to try to do this without a calculator and see what I can come up with, okay? So right here, I've got the 5th root of 3. I changed it to a radical, okay? And then I'm dividing this by another radical like this. Now here's kind of a cool rule. Well, all I did is I took this and I put it into a radical, and I took this and I put it into a radical. This actually equals, this is kind of pretty cool, all right? The 5th root of whatever 3 divided by negative 96 is, okay? So 3 goes into 96. If I did 96 divided by 3, you can see that that equals a 32, okay? So this actually becomes, ready? The 5th root of negative 1 over 32. So this reduces to 1 over 32. Now I just want to let you know, if you have an odd index and you have a negative, you know a negative is going to come out because it's odd, all right? Now watch this. I'm going to change this, all right, to, let's see if you guys can see this, all right? 2 to the power of 5, okay? 2 to the power of 5 is 32. So 2 to the power of negative 5 is 1 over 32. All right, it's 1 over 32. Or I could say 1/2 to the power of 5. All right, 1/2 to the power of 5 is also 1 over 32. So I'm just going to change it. I'm going to take, I already know the negatives out. So I'm going to take this right here. I'm going to change it to 1/2 to the power of 5. Now, here's the cool thing. This is looking for groups of 5. So if I have 5 of them, I literally can just pull out a half. If you're wondering what I did there, if I have 1/2 to the power of 5 over 5, so if I take this 5, put it in the denominator, put this 5 in the numerator, these just cancel to a 1, and that still gets me that half. So I think my answer is going to be negative 1/2. But like I said, you can do it in what? You can do this in the calculator, right? So let me see. Let me take a look at our original problem. All right, got it. All right, take a look at our original problem. Go to our calculator, hit alpha y equals enter. I'm going to go 3 to the power of 1 divided by 5. And then I'm going to go down here. Now, how do I get the 5th root? It's kind of cool. You got to hit the math button. You go down to number 5. Then you put a 5 right there. And then here you put a negative 96. I think that's what it was. Make sure. Yeah. All right. Sweet. Then you just press enter and you're like, what? Negative 1/2? That's all I got to do? Yeah, but for this one, that's what you could do in the calculator. But I showed you how to do it by hand because I'm awesome. Well, that's what C-Swizzle says, but he tells me I'm awesome all the time. So thank you, C-Swizzle. You're awesome too. All right. So right here, I'm going to type in. Nobody's going to watch this video anyway, so it's not like negative 1/2. Hold breath. Nailed it. That's right. Okay, what the heck are we doing here? We'll figure out if things are equivalent or not equivalent. So what I'm trying to do is I'm trying to see if this is equivalent to this. Okay. All right. I see what you're doing here. So right now we have what? 8m squared minus 2m. Now, if you guys know the quotient property, I don't know if you guys remember the quotient property of m over n. You're allowed to take the exponents and do what? You're allowed to, not rational exponents, sorry. I messed up. b to the power of m over b to the power of n is b to the power of m minus n. So watch this. I'm going to rearrange this. I'm going to put m squared up top and put 8 and a 2m right there, because this could totally equal this. And wait a second, that's a 2m. Ooh, this should be 8 to the power of 2m minus m squared. Oh, that's not equivalent. That's not equivalent right there. Okay. All right, so let's see if we can rearrange this real quick. All right, so by the way, I could separate this out right here. So I'm going to erase this part. The first one's not equivalent, all right? All right, so right now I'm going to take this guy, and I'm going to see if I can rearrange him just a little bit more. All right, ooh, let's use the product property. All right, put times 8. All right, put negative m squared. Okay, there we go. 8 negative m squared. So this right here, all right, would be, if I add those together, that would get me back to my original. All right, so let's see here. I'm going to rearrange it real quick. So once again, what should we be leading out with? We're leading out with 8 squared. So I'm going to put 8 squared m minus m squared. And then I got to put 8 2 to the power of m times 8 to the negative m squared. So I don't believe that's not going to be the same either. All right, so that does not look equivalent. But this one does look equivalent, because if I use the quotient property, that is 2m minus m squared. That does look to be equivalent. So I'm going to choose not equivalent, and equivalent, and we'll see if I'm wrong. If I'm wrong, I'm wrong. But these do not look to be equivalent, but that one definitely looks to be equivalent because I can use the quotient property. But you know what? I'm going to test it with numbers. All right? Let's test it with numbers. What if we said m was equal to, let's say, 3? So I'm going to plug in a 3 and see if they're equal. All right, so right now I'm going to go to my calculator. All right? I'm going to put alpha y equals, enter. I'm going to put 8 raised to the power of 2 times 3. Okay? Then I'm going to go down here and do 8 to the power of, let's see what we got. I think it's, oh, so we put 3, and that one's being squared. All right, we get 1 over 512. All right, so I'm going to go ahead and type it in this one, see if it works. So I have 64. So I'm going to type in 64 raised to the power, open parentheses, and I typed in a 3 for m, so I'm going to put 3 minus 3 squared. Close it. That is not equal to 1 over 512. All right? So this is not equivalent to this. But watch what happens when I do this one right here. This should be equivalent. So 8 to the power of 2, open parentheses, 3, close parentheses, minus, open parentheses, 3, squared. If I press enter, hit math, enter, enter. Do you see how I've hit, these definitely are equal to each other? So I just plugged in a number to see if it works. So I'm going to say not equivalent, and equivalent. That's what I'm going to choose. Nailed it. All right, next question. Oh, last question. All right, last question. Here we go. So we have 2/3 to the power of x plus 4 minus 2/3 to the power of x. And we want that to equal a times the power of 2/3 x. Now, the first thing we're going to use is what's called the product property. Watch how I separate these. It's very, very, very easy. All right, we're going to take 2/3. We're going to raise it to the power of x. We're going to multiply it by 2/3 raised to the power of 4. So using the product property, which states this, if you have the same base and you multiply these together, if they have the same base, what are you allowed to do with the exponents? You're allowed to simply do what? Add them together. So when you're allowed to add them together, you can also break them back apart. And that's what we did here. We broke this apart into this and this. So this was kind of breaking it down into its pieces. Minus 2/3 to the power of x equals a times 2/3 to the power of x. So right now, this has a common factor. I want you to notice this is being multiplied to this, and we have that factor right here. So that allows me to do something called factor something out. Now, if you don't know what factoring something out is, like I have ab plus a, I can factor out an a, and I'm left with b plus 1, because a times b is ab, and a times 1 is a. All right, so that's what I'm be doing here. I'm factoring it out. So I'm factoring out a 2/3 of x out of an expression. So if I factor it out, I'm left with 2/3 to the power of 4 minus, if I factor this out, I'm left with a 1. And that's all equal to a times 2/3 to the power of x. Now, I want you to see what matches. Now we have this on this side of the equal sign, and we have it on the other side of the equal sign. So all of this right here has to equal a. So this is where I'm going to plug it into the old graphing calculator and come up with an answer. So I'm going to take parentheses 2 divided by 3, close parentheses, raise that sucker to the power of 4, and then just put minus 1. And then hit the math button and press enter twice. And I get negative 65 over 81. Yes, that's ridiculous. It's a ridiculous answer, but I'm still going to trust my process. 2/3 to raise to the power of 4 minus 1 is negative 65 over 81. So a would have to equal negative 65 over 81. I'm just going to trust in my process, even though I got an ugly answer. Negative 65 divided by 81. If I got it wrong, then I did something wrong in the process. But if I got it right, that means I did everything right. So yes, that is an ugly answer, but the process is this, and I'll quickly go over it. The first thing I did was I took this, and I separated it into two pieces. So I took this x plus 4, and did 2/3 times the x times 2/3 time to the power of 4. Then I factored out the 2/3, which left me with this expression. And this expression ended up equaling my a value right here. And that's all I can do. So hope you guys have a good day. Hopefully some of it made sense. If it didn't, just ask somebody smarter than me.